Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned the derivative of the function given in the fraction form, just like numerator by denominator, using the derivative of that function using the quotient rule. Of exercise number 2.3 related with chapter number 2 differentiation second year or FSC part 2 mathematics. In today's video, I am going to solve question number 3 related with the topic of find an equation of tangent line to the given curve at a given point or at a specific point. So in today's question number 3, there are total 4 parts. So let's move toward the question. It is that find an equation of tangent line to the graph of a function at a particular point in the following problems. There are total 4 parts. Part 8 is that a function is given f of x is equal to 3x minus 7 at a point 3 and 2. Now move towards the solution of part number A. Let's suppose f of x is equal to y, so y will be equal to the 3x minus 7. Now differentiate both sides with respect to x, so it becomes dy by dx will be equal to the derivative of x is 1. 1 multiplied 3 gives us a value 3, and the derivative of a negative 7. 7 is a constant, so the derivative of a constant is 0. So it means that dy by dx is equal to 3, which is equal to the slope m. You know that derivative of a function is actually equal to the slope. So dy by dx is equal to 3, which is equal to the slope m. Now after this, we have a function given f of x is equal to 3x minus 7, y is equal to 3x minus 7. Now we have an equation given for the tangent line that y minus y1 will be equal to the m multiply x minus x1. This is an equation of tangent line. Now putting the values y minus, this is y1 and this is x1, which is given for the part A. So y1 is 2, so put 2 over here, is equal to m. M is the slope, which is equal to the 3 multiply x and minus time of x1. x1 is actually equal to 3. Now by simplification, it becomes y minus 2 is equal to 3x minus 9. So it becomes y is equal to 3x. So shift minus 2 to the right hand side, it becomes minus 9 plus 2, which gives us a value minus 7. So this is actually equal to the required tangent equation of f of x is equal to 3x minus 1 at a point 3 and 2. Now move to part number B of question number 3. A function is given f of x is equal to x cube at a point x is equal to negative 1 over 2. First we are going to find the value of y. How? So move towards the solution of part number B. Solution f of x, let's suppose this is equal to y, which is equal to x cube. Now our x is equal to negative 1 over 2. So by putting negative 1 over 2 over here in the place of x, so it becomes minus 1 over 2 power 3. Remember, when inside we have a negative sign and the power is r, so the result must be negative for the when the power or exponent is r. So in this case, the answer will be in negative form. 2 power 3 is actually equal to 2 multiplied 2, 4, and 4 multiplied 2 will be equal to 8. 2 multiplied 2 multiplied 2 gives us a value 8. So it becomes minus 1 divided by 8. So this is actually equal to the value of y. Now we are interested in the equation of tangent line to the curve at x is equal to negative 1 over 2 and at y is minus 1 over 8. So at these two values, we are going to find the equation of tangent line. Now equation of tangent line is y minus y1 is equal to the m multiply x minus x1. Now here we are given with y1 and x1, but we are not given with m. How can we find this m? This is actually equal to the slope. So we have a function given f of x, which is equal to y is equal to x cube. Now taking the derivative of both sides with respect to x, so it becomes dy by dx will be equal to the 3x square, and this is actually equal to the slope m. Now putting the values, it becomes y minus y1. This is actually y1, so y1 is actually equal to minus 1 over 8, so it becomes plus 1 over 8 is equal to m. M is actually equal to the 3x square. Now x is minus 1 over 2, so minus 1 over 2 whole square gives us 1 over 4. So it becomes 3 divided by 4 multiply x minus x1, so minus multiply minus gives us 1 over 2. Now after simplification, it becomes y plus 1 over 8 is equal to 3x divided by 4 plus 3 multiply 1 gives us 3 and 4 multiply 2 gives us 8. Now multiplying both sides with respect to 8, so it becomes 8y plus 1 is equal to 6x and plus 3. Now by simplification, it becomes 8y is equal to 6x and shift 1 to the right hand side, it becomes 3 minus 1, which gives us a value plus 2. So 8y minus 6x and minus 2 is equal to 0. This is actually the equation of tangent line to the given part number B. Now move toward part number C. A function is given f of x is equal to 1 divided by x plus 3 at a point x is equal to 2. Now move towards the solution. we have the value of x is given. First we are going to find the value of y. So f of x is equal to y, which is equal to 1 divided by x plus 3. So after this of putting the value of x, it becomes y is equal to 1 divided by x plus 3. X is 2, so 2 plus 3 gives us a value 5. This is the value of y. So our point will be x, which is 2, and our y is 1 over 5. These are the points. At these 2 points, we are going to find the derivative, the equation of tangent line. First, we are going to find the derivative of y is equal to 1 over x plus 3. So here the power of x plus 3 is 1. So by moving to the numerator, the power will become a negative. So it becomes x plus 3 power minus 1. Now using the derivative rule. So dy by dx will be equal to, using generalized power rule, the power will comes to the front. And after this we will subtract 1 in the power. So it becomes x plus 3 power minus 1, and we will subtract 1 in the power. And also take the derivative of the inner function, which is x plus 3. So the derivative d by dx of x plus 3. So after simplification, dy by dx is actually equal to the m, which is equal to the minus 1 multiply x plus 3 whole raised to the power minus 2, and this derivative is actually equal to 1. So this is actually our slope. Now using equation y minus y1 is equal to m multiply x minus x1. So by putting the values becomes y minus, our y1 is actually equal to the 1 over 5. So by putting 1 over 5, it becomes m. M is minus, so here put x is actually equal to 2. So 2 plus 3, so it becomes 2 plus 3 gives us a value 5. 5 power minus 2, it becomes 5 power minus 2. So it becomes minus 1 over 5 power 2. So it becomes minus 1 over 25. This is actually slope. So minus 1 divided by 25 multiply x. X1 is actually, this is y1 minus 1, x1 is actually equal to 2. So it becomes x minus 2. So by multiplying 25 to the both sides, it becomes 25y. It becomes minus 5. It becomes minus x and plus 2. Now by simplification, 25y is equal to the negative x will be equal to the plus 7. So this is actually equal to the required tangent line. Now move toward part number D, which is the last part of today's lecture. Question number 3. F of x is equal to x divided by x minus 2 at a point 3 and 3. This is x1 and this is y1. Now after this we are going to find the derivative of this function, which is actually equal to the slope. So f of x is actually equal to y, which is equal to x divided by x minus 2. Now after this, using the quotient rule for finding the derivative of this function. Quotient rule tells that the second function x minus 2 multiplying the derivative of first function, so derivative of this function is 1, minus time of this function, derivative of this function will be equal to the 1 divided by x minus 2 means the second function whole square. This is actually the derivative using quotient rule. So it becomes here it is actually equal to x minus 2. So x minus 2 multiply 1 gives us x minus 2, and here it becomes minus x divided by x minus 2 whole square. X is cancelled out with negative x, so putting the value of x, which is 3. So 3 minus 2 gives us 1, 1 square gives us 1. So we are just left with minus 2. This is actually equal to the slope, which is equal to the dy by dx. Now after this, using the tangent equation, which is y minus y1 is equal to m multiply x minus x1. Now y minus time of y1 is 3. So put 3 over here, multiply is equal to m. M is actually equal to the derivative, which is minus 2. So minus 2 multiply x minus time of x1 is 3. So by simplification it becomes y minus 3 is equal to minus 2x and plus 6. Now by simplification it becomes y is equal to negative 2x. Shift minus 3 to the right hand side, it becomes 6 plus 3, which gives us a value 9. So this is actually the equation of tangent line to the given curve at a point 3 and 3. So with this question I finished my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about second year mathematics differentiation chapter number 2. Thank you.